So I want to talk today about how you can become a whole lot happier with a Python project that you've taken some ownership over. So quick show of hands here. Has anyone taken over a project before and they've looked at it and go, what the heck was this? Like, what on earth is all this code? Because I've done that. I'm glad about, I don't know, I'd say 60% of people. Let me vectorize that real quick. So looks like, right, this is a common problem. And hopefully this talk won't just tell you about everything that you can, have done in the past and go, oh, I could do this next time. Also in the future, yeah, look at these tips. Hopefully these things will help you in the future. So I want to tell you a quick story, and I want to sort of give this talk in the form of a story a little bit as well. And the reason for that is that this has just happened to me, and I just try to deal with it, and I want to tell you how it went. So basically, I work for a company called Vonage. I've just shouted at the mic, I'm so sorry. I work for this company here, and also this company here. And they, right? So what they do is they do communications APIs. So stuff like if you want to send an SMS, or you want to automate a voice call, or if you want to do things like video chats, verification, two-factor, all these kinds of things. Basically, there's APIs for those things. When I joined as a Python developer advocate, and my job was to deal with the developer tooling. So our developer tooling kind of looks a bit like this and this. Oh, the laser works. This is an Amazon buy recently, so I'm not entirely sure how long this will last. But basically, I had mostly these two repos to look after. And these are open source repos that people had sort of started to write, which basically let you call our Vonage API code, but in a way that meant that you were using Python rather than calling it with curl or something like that. And so we had a bit of an issue with this in that when I got there, we hadn't really, looking at the code, it hadn't really been given, I guess, the love and attention that maybe it kind of deserved, right? So I think the issue here is that we really wanted to make sure things could be better and really improve things. And so I want to give you some examples of how we did that. And I'm going to focus mostly on this SDK here, this particular piece of code, because it has most of our APIs in it. I don't know why I'm walking so much. I feel like I should come over there soon and give you guys some love. I'll do that in a bit. So before we do that, I want to talk about what we'll discuss today. So first of all, we'll talk about how you get to grips and actually understand a project. Then we'll talk about how you actually start making some changes that are sensible to improve things. Then we'll talk about enhancements and how you can bring this forward, bring it to the next level, and bring it up. And then we'll talk about handing over that project to someone else and maybe letting them have a good time when they onboard onto a project. Does this all sound good to everyone so far? Open question. That is a lot of thumbs up. I love you guys. OK, so what do you get? What are you guys going to get out of this? Well, first of all, hopefully some strategies for dealing with this. If you are one of the 60% of people in this room-ish who put your hand up earlier, then hopefully these things will be familiar to you. If not, we'll learn some stuff. Also, I have got a checklist of all this talk. I've put it onto GitHub, so after the talk, you can refer to it if you're interested, and if you want some support in the future, you can always reach out and we can talk about that stuff. So a quick disclaimer before we get started. First of all, these are the ideas that I've had in terms of dealing with my own project. It might not all apply the same to you, so your mileage may vary on this. And finally, I am not a doctor, I'm not a lawyer, I'm not a financial advisor, so this is not legal, medical, or financial advice. Please take it all with a very big grain of salt. All right, so time for part one. Time for part one. So, part one, understanding the project. And this is the key. You've come to this project, you've been given it. It might be an external thing like mine, it might be open source. It might be something internal. It might just be there's a lot of data people in the room, I know. It might just be a load of scripts that are in a file somewhere, in which case, good luck. But when you're understanding a project, the first thing I would say to do is really try and read and understand materials about this. So there will be some documentation somewhere in some form that should be readable in some way. So for me, it was a bit easier because we have an open source repo on GitHub. So there's a README, and actually at a certain point in the life of this repo, it was pretty well documented. And so I was able to use that to understand what we should do. So speaking of using that code, actually the next thing that I would say to do is make a hello world. And this stuff should be pretty sort of self-explanatory, but for me, this company does, I just electrocuted myself, interesting. This company, I'm trying to get my phone out and wave it around. I'm going to try that again. Round two, we have a phone. So basically, with this code, with what Vonage does, we do things that communicate with people. And so I decided my hello world should be to send myself an SMS, so send myself a text message, right? And so that's what I did. And I wrote a very small piece of code. All it does is it sets up a client, and then it sends a message to a phone number of your choice. And it worked. Hooray, this is a very small win, but I appreciate the small claps I'm getting. So this basically was just enough to tell me, okay, well, I understand a little bit about this code now. So next question for me was what's actually inside my SDK, inside my code. And so I'm going to give specific examples here of my code, because that is what we're going to use as an example here. Obviously, it won't be the same for you. But there's a client class. There's methods for making requests. There's methods for generating JWTs. And there's also methods to call every single API. I'm reading the presenter view, not the forward view. That's what I'm doing. So basically, there's quite a lot of stuff in here that all is focused around making API requests. And we actually have quite a lot of APIs, as you can see, just that were in this SDK originally. Since then, I have added a couple more. That's been part of my job, is to keep adding new stuff, and we'll talk about how to manage those changes at the same time. But what I want to talk about as well is just the fact that read your source code and read the structure as well. Don't just look at the files, look at how they're organized, because that can tell you quite a lot. In my case, this wasn't super useful because I can't see everything I might expect to see. So what I did was also look at my tests. If you work on a data science project, you may not have tests, in which case, again, good luck. But if so, if you're working on a software project like I was, you probably will have some tests, so that'll help. And if so, the next thing to do would be to set up for development and actually run those tests. So, install what you want from that requirements file, and then actually run those tests. And ask yourself this question. Okay, so for me, the answer was absolutely not. They totally failed. It did not work. So I had to look at, well, why is that? What's broken these tests then, right? So a few things can break them. Common ones, new Python versions that you're trying might not be compatible with that code, or new dependencies might not be compatible. I'm seeing some sighing and depression in the audience, so I know that this is relatable. I appreciate that. It's how I felt too. So basically, for me, the problem was that I was testing on Python 3.10, and the code actually didn't support Python 3.10. So I had to then work out, by going back and working out, like by rolling back, what was the problem. So what I did was I created a virtual environment for Python 3.7, and I started there, and I went through until I found the problem. So I'd say, check the earlier versions and upgrade all of these things incrementally, and eventually you will find the problem. Final bit of this section here, understanding the call stack. So this is a great call stack. It's very representative of a lot of code, as you know. So basically, this is quite a useful way to actually understand how you can step through and what your code is actually doing. So when I had I'm going to leave my phone in Portugal. This is what's going to happen. I'm going to put it here, I'm going to walk off, and I'm going to forget. So basically, when I sent that SMS message to myself earlier, I had that code. And what I'd like to do is understand what it does and how it actually fits together. I'm going to regret that. And how it actually fits together. And so what I did was I used a profiling tool called SnakeFizz. Has anyone heard of this tool? Like one or two? OK, good news. This is a great tool. It's great, honestly, for basically any type of Python project. Because what it lets you do is profile your code. In fact, I'll show you. It takes a profiled file, a prof file. It takes your code that's been profiled, the stats about it. It returns an Icicle Plot, and the result is joy, because you get to understand your code better, and you also get to advocate for the performance of it, and you get to also optimize it. So doing that with my SMS code earlier, this is what we do. We just profile that code. We dump it into a prof file, and we end up with an Icicle Plot that looks like this. So this is actually a graph. It may look like a table. It's a graph. I'll explain how it works. So basically, the first part, the top part here, this top bar, that is the function that I'm profiling. And everything below that is everything that this function is called. And so I can actually see that underneath the actual call, it's actually calling the SMS API in the SMS module, and so on. It's calling the client stuff. It's setting up a session. And I can actually really understand my call stack this way. So this is super, super helpful if this is what you're interested in doing. So summary from part one then. First of all, you want to gather information about the code base that you can. You want to make a hello world and understand the code. You want to get those tests passing if you have tests, and if you don't, again, good luck. And don't forget to explore the call stack as well, because this can really help. So are we all happy so far? Is this making sense to everyone? I hope so. It's all good. I'm getting a lot of thumbs up. I like this. Let's do more of it. Cool, thanks. I appreciate the support, guys. So let's move on then. This is my slide that gives me an excuse to stop and drink some water. Feel free to read it. Thank you. Obrigado. So project structure. This is the point where you're actually ready to start making some changes. And so this project structure is the first thing that I wanted to look at, because I had a project that essentially had this structure here. So I had a structure where I had an init file, okay? I had some internal thing, don't know what that is, that's fine. I've got voice, verify, and SMS. Those are 3 of our APIs, 3 of the 12 APIs that were currently in this code, so where are the rest? And then a file for errors as well. And so I did ask the question, well, where are all the other APIs, and where's all this code? And it turns out, there we go. It turns out that actually all of this was in the init file. And in fact, this file was 798 lines long. So obviously that's not currently a best practice, right? We want that to be as minimal as possible. And so maybe let's dig into that file. So for me, if we cat that out, what you'd see is you'd see the main client class. You would see methods to call every single API. You'd see deprecated methods. You'd see methods that actually weren't marked as deprecated, but the endpoints from Vonage had been deprecated, so they totally wouldn't call. You also had logic to generate JWTs. You had base API requests, and you had some optional settings as well. So I ask you all an open question. Can we do any better than that? I'm seeing yes, I agree. And because I agreed, I actually did try. I tried this myself. This is my interpretation. So the core logic I put into a client file. Our APIs I split out into different modules. And our errors, they're fine. And our internal stuff, that was also cool. Although actually our internal file had one of the APIs in it. Gave that its own file. So that's where we ended up there. So if you were to do this yourself, so this was very specific to me. Stuff for you, I would say to separate similar functionality into different modules. Try and create classes that can hold similar methods, and then they can have their own properties that they're shared, these kinds of things, and create some custom errors for those classes so you can actually throw relevant errors, and you can throw them higher up in the call stack so you're not digging in through 100 lines of code if you're a user there. Does that make sense? Awesome. Let's talk about choosing the right dependencies, because there may be one dependency for your project, there may be 1,000, but you're probably going to have at least one. So the first thing I'd say that is important is a permissive license. So this is just something that people sometimes overlook. But if you're trying to think of a dependency, then you need to have a license that is going to allow you to use it. So if you're a commercial project, then Apache, MIT, a good time. GPL, avoid. This is the most technical and business sense this is going to get. But don't get screwed over, is what I'm saying. Okay. So it's quite helpful if dependencies are popular, because it means if you Google it, there'll be answers, there'll be help, there'll be Stack Overflow people ready to help you. It's good if this stuff is well documented, for obvious reasons. It's good if it's actively maintained, and this is really a key. Unless it's like so simple that you don't have to do anything, and it's just, it writes itself, then really you need these things to be actively maintained. And I would say that a big important part of this is that you should continue to qualify these dependencies over time. So what I mean by that is, okay, your dependency right now is being maintained, it's really great, it's, I don't know, the request module, we use that, right? That's great, but in 6 months' time, is it still going to be maintained? If a lot of these projects are open source, they might not be, right? Make sense? Awesome. Let's talk about other things. For example, testing code that you don't own. So this is a problem that I kind of have in my work, and a lot of people will too if you deal with things where you make stuff happen with your code. So I've got a Python SDK here, and what that does, right, on the base level, is it makes API requests, and that's all it does, right? It makes API requests by, creating a session and shoving them up into the sky and hoping that somebody will answer. It then passes that response. That's all I can really own from this code, right? So if I take a really, really simple example, for example, sending an SMS, again, if I take this example, then the code looks something like this, right? So I send an HTTP request to a Vonage server, and I get a response back, right? But actually, this then sets off through a load of network stuff. It basically sends a message to a user, and that status information comes back, and it comes back to a callback that, as a developer, you can then view. So that's a URL you can set. And this all happens, and we don't control that. So the only part of the code we actually own is this bit, right? So you've got to think about, what do I actually own? And then with your tests, you've got to think, well, what am I actually able to test? And so really, all of the tests that I can do that deal with functionality come down to one question, and that's this. It's, are those requests well-formed? Because that's all we have control over. Are those requests sent in the right way, that they'll be appreciated, and then will we also be able to pass that response? That's it. So just think about when you're writing tests, what you're able to own, and what the real questions are that you can answer from your code base. Does that make sense? Awesome. Everyone laughs when I drink water. Should make money doing that. Right, moving on. Let's talk about branches. So hopefully you're commit history doesn't look quite as bad as this in your version control system. Mine luckily didn't. Will this reach? No. Yes. OK. Ideal situation here. An ideal situation is that you have something like this, where you've got your main thread. Glad I moved now, yeah. That fiber extension has just collapsed. So basically, when we've got an ideal situation, we develop a feature, we merge it in, we develop a feature, we merge it in. In our current SDK, we've got a beta branch, because currently I'm implementing a video API, so I'm putting those beta features onto a beta branch that will be long-lived, and that's OK. But when I kind of joined the company, and when I looked at this code, it looked a lot more like, wait for it. I'm going to have to stay over here, I'm sorry. Sorry, I do love you. I love you just as much as those guys, but I can't give you the same attention. I love all my kids equally. So when I got to the company, it looked a lot more like this. So there were branches that had just come off and were never merged in. They had different features, different bits of code on. And in this situation, the first sensible, logical thing to do is to make this face again. And once you've done that, I would say thank those people, because what it's done is it's given you an insight into the previous work that was done with this code base. You can also investigate it to find out some inspiration and to sort of work out, oh, what were they doing? Well, maybe I could take this idea. Maybe I could take this to completion, But also say, close down as many of those branches as possible, because once you've understood what's in those, you want to have a blank slate as much as possible when you're actually developing, right? You want to have the stuff in the way that you're ready to put it in. So let's talk about making your first release, and specifically trust. Because when you make a release, like, I know some people here might be sort of more on the scripty side and the data side, but when you make a release of sort of a software project where users are going to use that project, you have to let them know that they can trust you. And you have to let them know that if they upgrade, you're not going to break all of their code. And so the easiest way to fix that is to use semantic versioning. So that's the kind of case where you have the three numbers, 1.2.3. The first number is your major release, and basically only increment the major release when you've made a breaking change. But whenever you do any release, update the changelog and update the README, because you need your users to know what they're going to get when they upgrade the code, right? I'd also say being transparent is key. You want them to know exactly what's going to happen so that they can trust your future releases. So, think about quite explicit changelog messages, things like this, just to really make things clear. So another thing that's important with releases, hello new people, how's it going? Hope you're having a lovely day. I'm having a great time up here. I almost got hit by a door earlier. So, right, easing in deprecations. This is important because probably when you have your code, like for me, all of my code was in an init.py file, and that was a bad time. So I wanted to deprecate that code and split it out. And so to do that, the actual deprecation was a minor release, but removal was a major release. And I would say just don't forget to think about the time between the deprecation and the removal. Because if you deprecate something one day and remove it the next day, your users will have whiplash from how fast they've had to update their code base, right? And that's not OK. Don't upset your users, right? They're the people who are like keeping this thing going, right? The people who need your code. So I want to talk quickly about balancing improvements and new work. And what I mean by that is that, like, if you've come onto a project, you've probably not been brought in to deal with technical debt. You've probably been brought in to add cool new features, right? So the thing is that you probably want to fix some of this stuff because it's going to make you just have a better time. So I would say work with your team on this. So talk about the situation, talk about the state of the code, set those expectations, advocate for yourself and advocate for the work that you're doing. Just explain why it's important that you're actually fixing this stuff, because you're getting rid of technical debt. It's going to be better in the future. And I would say this has really helped me, actually, is to have tickets for discovery. And what I mean by that is that we, in my team, we track stuff by, version stuff like, but we use Jira. I'm sorry, we use Jira. I'm really sad about it, but we do. But we use, basically, we have tickets that I actually put in to say, I'm going to learn about how this thing works. And that's useful because it's not, hey, Max is going to sit around for a week. It's Max is going to do something useful that's adding value to the future, code base that he's going to write, right? By the same time, the same token, think about having tickets for technical debt. Because if you have a ticket for technical debt, again, people can see what you're doing with your time. So a quick summary here. First of all, use a Pythonic structure and think really carefully about your dependencies. Make sure that your tests actually make sense. Remove branches that you don't need. Be really careful with your deprecations. Set the expectations of your users and with your team, and then build trust overall as well. Are we all cool with all of the stuff we just talked about? I love that thumbs up. Most confident one I've seen today. I love it. Okay, part 3. This is just a little section about some stuff that I've actually started to add to the SDK and just want to really show you about some things that can add some value, hopefully, to you too. So first thing with error handling is that I've started trying to add some custom errors and more specific cases for these errors. Because basically, if you're a user using something and something breaks, you want to know as early as possible in the stack what your code did wrong, right? So that's important. So one thing I did this year was implement an API called the Messages API that basically lets you do not just SMS and MMS, but also WhatsApp messages, but also Facebook messages, but also Viber messages. And to do that, I had to deal with some very specific cases of things a user could get wrong when they're actually trying to send this request. For example, if they try and specify a channel that doesn't exist, we've got to deal with that. So there's a custom error for that class, but also I've actually got a custom message that comes out telling them what they put in that was wrong, right? And this is really helpful. There's actually a slightly even better way to do it that we'll talk about shortly. But let's right now move on, switch gear, and move on, switch gear, and switch gear, move on, and talk about async. So, I'm sorry, I've not got to do an async joke yet. Anyway, well, I'm glad people laugh. It means I'm in the right room, right? Thank you. So very, very pitiful laughter. So operations, basically with async. So if you're not familiar, how it works is that typically with synchronous code, you write your code, it does something, and if it's waiting for something to happen, like update this database or make this request, it's just going to hang. But with async, operations can give up control to the Python interpreter, which means that you don't have to do that waiting step, which means that actually if you're doing lots of IO-bound operations, this can really speed up your code. So a real-life example of this, I want to just show, here's a synchronous piece of code. And this is a piece of code that just calls our number insight API, which gets information about numbers. It just does that 100 times about 100 different numbers. And if I use that snake viz tool I told you about earlier, is that photo good? You got it? Cool, going to move on. So if you use that snake viz tool we talked about earlier, we can actually see it took 3.4 seconds to do those calls. Not terrible, but actually all of the time, if you go down, is actually spent just making this request. And if we go all the way down the stack, it's literally just waiting for a connection for most of the time. So that's significant, like 2.8 seconds out of 3.4. And so the question is, can we do any better with this? And so an async version of this code looks similar, except this time round, we actually bundle this stuff and we do it asynchronously. And if we do this, then when we get to snake viz and we visualize this code, we can see it took 0.3 seconds to run, which is literally 10 times faster. So for us, there is a strong use case to consider async. But what I would really say is that unless you really want to do async, maybe don't, because right? Because async functions are not the same as regular functions. They're actually coroutines. They're more like generators. You can't use them the same way. You can't just call them trivially. You've got to set them up and properly package them, run them. You can't just call them. And for that reason, there's quite a large outlay to actually build that stuff. You've got to support multiple libraries if you want your users to still be able to use synchronous code. You've got to do a lot of stuff twice because you've then got to implement new stuff into those libraries. So do question, do I need this? And if you don't, have a good day, So finally here, I want to talk about input validation. And I want to talk about the fact that we take a lot of stuff, from users, take lots of input and do stuff with that. So a real life example here is this Messages API again. We've got a very complicated OpenAPI spec that we use. That has loads of different cases here. And to actually make sure that the user can just write a function like this and just pass something in to send an SMS or a WhatsApp message, we have to do a lot of validation and checking in the back. As you can see, there's quite a lot of different checks that I do to actually make sure that the user isn't going to put the wrong thing in. And those checks are non-trivial. Like they're not super hard, but they are very fiddly. And it would be great if there was a tool that could just do this for you. And if we've been to the Fast API talk earlier, we'll know that Pydantic is an option. So what is Pydantic? First of all, it's a validation library that's based on models. And what it does is it enforces type hints at runtime. And that basically means that if you put something in and you don't get the right input, it will throw a readable error for you. So making this code Pydanticified, I just added a couple of models, so a message model here and an SMS-specific class of that. And basically, as a user, all I have to do is create one of these models, pass that in. And now if I don't do this correctly, I'll get a human-readable error. Make sense? And the advantage for me, as the maintainer of this SDK, is all that code earlier I showed you, I can bin, right? So it's kind of better. So is it worth it? I would say probably yeah, in a lot of cases here, if you want to care about your data that you're sending. And it can also make your testing a bit easier, because you know by construction if your thing's going to work or not, right? So a quick summary here. Specific error types. So I would say, yeah, make specific error types to catch things earlier in the call stack. consider async, but only if there is an extremely strong case for async, and I mean a really good strong case for async if it's not a sync library. And finally, yeah, if you want to do input stuff, you look at Pydantic, have a look, try it out. It's really nice. Are we all cool so far? Yes. Okay. That was 4 when I got up here. Okay. Final part then, and this is, okay, it's 1 slide, but I'm going to call it part 4, handing over, okay? So it might be the situation, I've been on this SDK for 6 months now, at some point I'm going to have to hand it over. And when I do that, how can I make sure that the person who comes after me is going to have a lovely time? So what I would say, this is a spicy take, but I'd say if it gets to 2 weeks until you're handing over, stop doing new work on that SDK. Don't do it, right? The time for this has passed. If you didn't get that feature in, you know, the next person's job is to do that feature. Your job is that handover. That's what you're going to do. Finish those PRs, merge those PRs. You're not going to, you know, you're not going to work on that stuff. Close those branches down so the user doesn't end up with that spaghetti example that we had. Finally, document the state of the code, right? Write a handover document. Tell people what you've done, right? That README should be updated. Your changelog should be updated. You should know when you get to that code what it's going to do and how it's going to do, and maybe also, you know, your future plans and what you're interested in, what you think might be the next logical step, right? So, final thing here is just to summarize. So I would say, first of all, right, learn as much as you can about this stuff. Make incremental changes to your code. Set expectations and build trust, not just internally with your team, but also externally with your users. You've got to build that trust. Also, yeah, add enhancements based on what the user actually needs. If your user doesn't need async, don't add async. If your user doesn't need validation, do not add validation, right? It's not worth it. So the final thing is just this, oh, it works. The final thing is just this checklist here, which is basically got all the content of the talk summarized into a nice file. And the reason it's there is because it's on GitHub so people can make PRs if you're interested. If you've got ideas, anything you want to share, please put it in there. I would just say again, thank you to my company for letting me basically prepare this talk in work time. It's been very nice for them. This is my final slide because I want you to scan that if you're interested. So thank you so much. You've been wonderful and I've had a great time talking to you. Cheers.